All right, everyone, let's get on it. We're looking at algebra again and Pythagorean Theorem part 2. In this one, we're actually going to look at some triangles, which is, well, it's kind of the whole point of the Pythagorean Theorem. So let's get started with that, and I'll see you in a minute. Here we go. This is the worksheet that we're intending to do. We're going to look at questions 1, question 7, and then question 11. Let's see if I can get down to it. Yeah, there it is, question 11. But we're going to do that not on this worksheet. We'll do this on something else. So let's take a look at what we have. All right, Pythagorean Theorem Part 2. We're going to start by reminding you about the Pythagorean Theorem. That's a squared plus b squared equals c squared. It's literally one of the most important theorems of mathematics. It touches so many different disciplines that I feel sorry for anyone who doesn't really know about this theorem. I mean, the ancient Egyptians knew this theorem. Can you believe it? That long ago? Here we go. C has got to be the hypotenuse of the triangle, and that's the long side. But the way that we're going to be approaching it today is that C is the side that's opposite the right angle. And then, of course, like yesterday, if a triangle is a right triangle, then the Pythagorean theorem is going to be true. And actually, it works the other way around also. If the Pythagorean theorem is true, then you have yourself a right triangle. This is actually the way that the ancient Egyptians and even builders today, this is the way that they use the Pythagorean theorem. They get numbers that they know will work with the Pythagorean theorem, and they just make their triangle out of those numbers. So it's a very advanced way of thinking. You can get yourself a right angle every time if you use the Pythagorean theorem. Let's take a look at this example. I think this is question 1. I always like to start out with the first one. Oh no, this is just a example of how the Pythagorean theorem works. Here we have a plain old right triangle. You're going to notice over there that there is a box right here. Now this box, this square, is always to indicate where a right angle is located in a triangle. You should also kind of know where the right triangle is in a right angle because it's where it meets at an L shape. That's a really basic shape that almost everyone can connect to. And based on where that right angle is, you can always tell the hypotenuse, or the letter C, because it's always opposite that box. That right triangle, that square part, is always going to point to the letter C. Now the letters A and B don't quite matter as much. You can interchange them as you like and you'll still get the same answer. Most of the time I like to let letter A be the piece that's horizontal and let B be the piece that's vertical, which is contrary to the diagram that you see over there. Well, no matter. Let's take a look at this question. We are supposed to figure out, this triangle is missing the length of one of its sides. We're supposed to figure out what that is. Okay. So we note, first of all, that this is a right triangle. You can tell because there's a right angle right here. So that means that C is opposite the right angle, and it is, well, the longest side of the triangle there is C. Now the other two, like I said last time, it doesn't matter which one's B and which one's A. I like to make A the one that's horizontal. So we got A is 11 and B is 6. If you wanted to switch them, you're not really going to get the problem wrong. That's not a major issue. The most important side of this triangle is C. So our clues: A is 11, B is 6, and C is, I don't know. Here are those clues again, and now we're going to use our algebra to solve. First of all, what is the Pythagorean theorem? It's a squared plus b squared equals c squared. Next step, you're going to put the numbers that we just figured out into the Pythagorean theorem. So a is 11, so 11 squared plus, well, b is 6, so 11 squared plus 6 squared equals, well, c is a question mark, so we don't actually put a question mark there. We're just going to leave the letter c and keep it squared. So we get 11 squared plus 6 squared equals c squared. Now we're going to perform any arithmetic we need to do. 11 squared is 121, and 6 squared is 36, giving us the equation 121 plus 36 equals c squared. More arithmetic. Add those two numbers together because 121 and 36 are on the same side of the equal sign. So if we add those two together, we get, what is that, 157? So this tells me that c squared is 157. And the way to solve when you have a square, well, just like we've been doing with our quadratic formulas, we're going to square root both sides. So the square root of 157 is c, which means c is 12.53. How did I get 12.53? I used my calculator. I asked Google. I asked Alexa. Doesn't matter. C is the square root of 157, which is 12.53. Easy, right? After everything we did yesterday with all our repetitive stuff, this is not that bad at all. Let's move on. Now we got number 7. Here's another right triangle. I can tell it's a right triangle because it has the box in the corner. And now I'm going to figure out where the most important side of the triangle is. Where is C? Well, it's opposite the box. C is 25. A and B don't quite matter as much. So this time A gets a question mark and B gets the 15. Again, if you switched it and you decided that you wanted A to be 15 and B to be question mark, it's okay. You'll still solve it correctly. There's our clues, redundantly with the clues, and then now we're going to begin the process of algebra with the Pythagorean Theorem. Write down your Pythagorean Theorem. Make sure you're writing it. Substitute your numbers. A squared plus 15 squared is 25 squared. Now you're going to perform all of your arithmetic. 15 squared is 225 and 25 squared is 25. Do a little bit of algebra. You need to subtract 225 from both sides because you want to make a squared equal to a number. So we need to get rid of that 225. So here's the way I'm going to do it. Subtract 225 from both sides with the equal sign. Again, this is what you're writing. And then that gives me a squared is 400. Which means a is the square root of 400. And what is the square root of 400? I don't know. Ask Alexa. Grab your calculator. Go to Google. You're going to get that a is 20. So the missing side of this triangle is 20. Okay, we're on a roll. Let's take a look at the last one for today, and it is, it's a word problem. You saw that coming, I'm sure. An 18-foot ladder is leaning against a wall, and if the base of the ladder is 7 feet from the wall, how high up the wall does the ladder reach? Well, first of all, you need to be able to visualize a ladder leaning up against a wall. And I don't know if you've ever seen a ladder leaning up against a wall, but I bet you have. And this is kind of what you should be seeing. There's my ladder, there's my wall, and of course the bottom is the ground. And do you see the triangle? Right about here. Do you see that triangle? Okay, the right angle is right over here. Now this time there's no fancy diagram to show me where the right angle is. I just kind of have to know that the right triangle is the angle that's made with the wall and the ground. So if that's the right triangle, that means that C is 18. Just like before, the other sides don't matter as much. I'm going to let A be the 7, which is how far away the bottom of the ladder is from the wall. And then the height of the ladder, how high the ladder reaches, I'm going to let that be equal to B. So B is unknown. I can tell you for sure B has got to be less than 18, right? Because if your ladder is leaning up against the wall and your ladder is 18 feet tall, well, that's got to be shorter than 18. So that's going to help me error check a little bit just to make sure I'm getting an answer that makes sense. Here's our clues written together, and we're going to import that into our next page. A is 7, B is unknown, C is 18. Write down the Pythagorean theorem. Just like last time, substitute the numbers. A is 7, B is unknown. Remember, you're not writing a question mark, you're just leaving it as the letter B. And C is 18. Perform some arithmetic that you need to. 7 squared is 49. 18 squared is 324. I had to look that up. I don't know this 18 squared off the top of my head. Algebra. I need to, oops, forgot to square B over there. Okay, algebra, I need to subtract 49 from both sides because I'm solving for B, and to solve for B, I need to get B on its own side of the equal sign. Anything else needs to be moved to the other side of the equal sign. So I'm going to subtract 49 from both sides of the equal sign. That leaves me with only B squared on the left. 324 minus 49 is 275. Again, calculator. And then square root. So B is the square root of 275. Now, grab a calculator. Calculate the square root of 275. Ask Google, ask Alexa, ask Siri. Hey, why not? You're going to get that B is 16.58. And that's it. If you can do all of that stuff, you have mastered the Pythagorean theorem as far as I'm concerned. So get to it, practice it, rewatch the video if you need to figure out how I did things, but get this done. It is one of the most important theorems of mathematics, and I'm not just talking about here in high school. I'm talking about in the history of humankind. We could not have done anything without the Pythagorean theorem. I'll see you guys next time.